Okay, this is the last section in this chapter. We always learn concepts and then we learn how to solve the problems, and then we always do modeling or application problems, which are word problems. Don't freak out. Again, they're just math problems. You just have to know what the letters stand for. Okay? So, right here, we're going to read the problem so that we know what X is. So we know what these X's stand for. They're the same thing. And we know what E stands for. Okay? So we're going to read it. The average weekly earnings E in dollars. So this is our dollars. It's our earnings in dollars. For a group of workers can be approximated by this, where X represents the number of years since 2004. So the X is the number of years since 2004. Okay, so now we go to the question, determine the average weekly earnings in 2007. Well, this is since 2004. Well, this would be 3 years later because we're going to say 2007 minus the 2004, and you just found that X is equal to 3. So now you take that 3 and wherever you see an X, you plug it in. And it says determine the average weekly earnings, which is our E. So you're going to have 0.12 times 3 squared plus 7.8 times 3 plus 555. You are going to let your calculator do that work. You do not have to do that by hand. Okay, so 0.12. I'm going to plug it in just like this. Parentheses 3 squared plus 7.8 parentheses 3 plus 555. And that says that our weekly earnings is going to be $579, and money is always 2 decimal places, but it gave us 2 decimal places, so we're good. The other way you could have done this problem is you could have said 3 store X. I still would want to write this down if this was a test question, so I would know that you knew what to do in case you plugged it into your calculator wrong. 0.12 X squared, okay, because sometimes you might put that decimal in the wrong place, plus 7.8x plus 555. Now just make sure you have that typed in there, and it still gives us the same answer. Okay, all right, now it says in what year did the average weekly earnings reach 638? So our E now is 638. So what we're going to do is we're going to plug 638 in for E. Let me do it down here. So we're going to have 638 equals 0.12x squared plus 7.8x plus 555. Okay, now I got to get it set to equal to 0. We just learned how to solve quadratics. It's okay that it's a decimal. So I am going to take this over here. I'm going to get it there by subtracting it. I get 0 equals 0.12x squared plus 7.8x minus, let's do 555, minus 638 on my calculator, and I get negative 83, so minus 83. Now, some will teach you to get rid of your decimals, and you can do that by multiplying both sides of everything you see, including the 0, which just gives us 0, by 100, because if I multiply by 100, this gives me 12. This is going to give me 780, and this one would give us 8,300. But we're still going to use the quadratic formula, so we've got the calculators. I'm not going to do that. I am going to say x equals negative b, so it's negative 7.8, plus or minus the square root of b squared, which is 7.8 squared, minus 4 times my a, which is 0.12, times my c, which is negative 83, all over 2 times my a, which is 0.12. Now, don't try to do this all at once. I am going to find out what number is underneath that radical. I'm going to do this on my calculator. 7.8 squared. Whoops, forgot my parentheses. Minus 4 times 0.12 times negative 83. Guys, this looks just like it does on my paper, except for I didn't finish my parentheses there. Now, underneath that radical, I get 399.48 all over, and when I do this, 2 times 0.12, I'm going to get 0.24. Okay? Now, this doesn't make sense because it says in what year. That doesn't even make sense to leave your answer that way. So it doesn't really tell us what to round to, but it's okay. We'll get to it. But we do know that if I ask you what year, you've never seen a year like this after the year 2004, because that's what the T stands. Oh, by the way, I put X because I'm used to X. Oh, it is X. Never mind. I was thinking it was T. All right. So now we're going to plug this into our calculator, however it is that you do it. Okay. A lot of you have the fraction key. So you're going to say negative 7.8 plus second square root of that divided by 0.24. Now it may give me a fractional answer. I need it to be a decimal. Okay. So it's approximately 50 point, let's just say 8. And what does that stand for? The X stands for years since 2004. So years since 2004. And so to figure out what year that would be, you just say 50 plus the 2004. So this answer would be 2054. You do not need that 0.8. Okay, you don't need that. It's kind of like telling me your birthday is in June. If you were 18, you'd say 18. You don't, in the year 2024. You don't say I'm 18 in 6 months, okay, or 18 point, well, it wouldn't be 6 because that'd be 10 months, but it just wouldn't be that. Well, actually, it'd be 0.5 because it'd be half a year. You just wouldn't say that. You just say the year was 2000. If I asked you what year you would be 18 in, you would say 2024. Okay, now that's the 1 year. Let's see what happens for the next, for the minus. So I'm going to bring this back up. And I'm going to change this plus sign just to a minus because I'm lazy. And that gives me negative. Well, that doesn't even make sense. My second year is negative 115.8 years since 2004. Time cannot be negative, so we throw that one out. So our answer here is this here because it says in what year. It doesn't say how many years after 2004. It says in what year. So our answer is 2054. Okay. Now again, don't let the formula confuse you. We have a capital N and we have a lowercase n. We're rather going to take the numbers and put it in for n, or we're going to take the numbers and put it in for lowercase n. Don't let that part confuse you. Read the problem to find out what both of these stand for. In a round-robin tournament, every team plays every other team one time. The number of games in, okay, so this is the number of games, is modeled by this formula, where n is the number of teams. So these little n's here are the number of teams. So in the question, if it gives you the games, you plug it in here. If it gives you the teams, you plug it in here, and then it's a math problem. We only read the word problem to find out what those two stood for. So now it says if 28 games, we're putting that in for our capital N. Were played, how many teams were there? Okay, so we're going to put in 28 right there, and we are left with 1/2 n times n minus 1. It's just a math problem. Do not let that 1/2 confuse you. If you want to change it to 0.5, that is perfectly fine. I'm just going to leave it because it doesn't bother me really, even though probably 0.5 would work out better. But I'm just going to show it to you using this. We're going to distribute. 1/2 n times n gives us 1/2 n squared. 1/2 times a -1 gives us a -1/2 n. All right, I've got to get it set equal to 0, so I'm going to subtract 28. Now here, I can make this a lot easier because we've already learned this, and I'm going to go ahead. If you want to, you can use quadratic formula, and you can use 1/2, or you can use 0.5. I don't care. It'll work, okay? But I don't want to get, I want the fractions gone. I want to get rid of them. So what I'm going to do is I'm going to multiply this side and this side by our denominator. The denominator here is 2. I'm going to multiply both sides by 2, because watch what happens. This gives me 0. And you don't have to do this. I just don't like working with fractions if I don't have to. 1/2 times 2, or 2 times 1/2, gives me 1 n squared. Gives me 2 over 2 n squared, which is 1 squared. Same thing here. 1/2 times 2 gives me 2 over 2, which is 1, so I have minus n. And then 2 times 28 gives us 56. Now, this factors. You can use quadratic formula. It will still work. I showed you that before on that first problem in the other section, that we factored it and got the same answers as if we use quadratic formula. But this will factor as n minus 8, n plus 7. Each factor that has an n in it, you set equal to 0. So I'm going to go over here. I'm going to say n minus 8 is equal to 0, and I'm going to say n plus 7 equals 0. So here I'm going to add 8 to both sides. Here I'm going to subtract 7. So I get n equals 8. And what did the n stand for? The little n stood for teams. So I have 8 teams. Here I get -7 teams. Does that even make sense? Can you have a negative number of teams? No. So you kick that out. Now don't think that all word problems only have one answer. Sometimes they will have two. We just haven't found it yet. Now we go, if there are 12 teams, how many games? So teams is our lowercase n. So wherever you see that, you plug in a 12. So you're going to have n equals 1/2 times our 12 times our 12 minus 1. You can let your calculator do all that. You don't even have to do this by hand. I just can do it. 1/2 times 12 is 6. 12 times our 12 minus 1 gives us 11. So 6 times 11 is 66, and N stood for games. There's going to be 66 games. But watch, don't worry about it if you can't do it in your head. Okay? You're going to say, well, you'll probably use your fraction key, 1, or you're going to use 0.5 because that's perfectly fine, times 12 times 12 minus 1. And then you get 66. Games. Always make sure you put your units. Okay, right here, the fatality rate, F. In fatalities per 100 vehicle miles driven for drivers X years old can be modeled by this. Okay, so this is a rate. The fatality rate. And these X's, now also this is per 100 million vehicles. We'll get to that. Don't worry about that right now. That's only going to be in your answer. For drivers X years old. So this is how old they are. This is their age in years. Okay. Approximate the fatality rate for drivers age 19. So are you going to put it in for F or are you going to put it in for X? Because it's age 19, the X stands for age. You're going to just plug it in wherever you see an X. So you're going to have this times 19 squared minus 0.35 times 19 plus 9.2. Okay, let your calculator do the work. Now, you can do it like this, or you can store 19, store it under X, and then just plug in this formula. 0.0036 x squared minus 0.35x plus 9.2. And there is 3 point, it doesn't say what to round it to, but we'll just keep it because it's not that long. Now, that is per 100 million vehicle miles driven. Okay, so it's not just 3.8. It's well, it's 3.8 in fatalities in 100 million. Okay, don't worry about it. Let's just go with it. Approximate the fatality rate for drivers age 50. Well, that's a good thing about storing it, because now all you have to do, if it was on a test, I'd want to see this part though. You can let your calculator do the work, but this is showing me that you understand what to do with the 50. Okay, but the nice thing is, if you use your store button, now all you have to do is say 50 store X, and then bring this one back up, and now you get 0.7 fatalities per 100 vehicle miles driven. Okay, we probably just should put fatalities anyway. Now, approximate for the age 85. You're going to plug in 85 here. Okay, so I'm just going to say 85 store X. I'm not going to write it all out again. I'm going to bring this back up, and we're going to get 5.46. So watch, it's a little higher, then it goes down at age 50, but then when they get older, there's more. So, and again, I just replace these with the 85. For what ages is the fatality rate approximately 2? Well, now you're going to plug in the 2 right here. And hold on just a second. In order to use a quadratic formula, you got to set it equal to 0. So we're going to subtract 2, and we get 0 equals 0.0036x squared minus 0.35x plus 7.2. Because when you subtract those, you get 7.2. Now we're going to use a quadratic formula. X equals negative b, so it's going to be a positive 0.35. Plus or minus, be careful here. When you square this, a negative, it's going to be a positive. It's going to be very careful. Now you could just put this as a positive, but when you go to plug this into your calculator, you need to put a negative in parentheses and square it, because that's going to give you that positive. Minus 4 times my a, which is 0.0036, times my c, which is 7.2, all over 2 times my a, which is 0.0036. Okay. Now, I'm not going to do this all at once. I'm going to see what that radical gives me. 0.35 plus or minus. I'm going to see what I get underneath here. Now remember, this has to be in parentheses. So you're going to begin in parentheses, negative 0.35 squared minus 4 times our a, which is 0.0036, times our c, which is 7.2. And underneath that radical, I'm going to get that decimal. I'm not going to round it. 0.01882, because that's what I had underneath that radical, all over 2 times this, which gives us 0.0072. Okay, 0.0036 times 2, that gives us that. Now, we're going to do this. I'm going to do it twice, one with the plus and then one with the minus. Okay, so the plus one, I'm going to alpha. If you don't have the fraction key, put the whole top in parentheses. If you don't have it, 0.35 plus second square root. I'm going to go up here and highlight it so I don't have to type it over. Divided by, I'm going to come up here and highlight that. Oh crap, it didn't do it. I thought it would, but it didn't. I'm going to just type it in, 0.0072. And you get approximately 67.7. So about 67 years old or 68. I would take either because it didn't tell us. Okay, it says for what ages. Well, let's see if it has a second answer. I'm going to bring that up. Oops. I'm going to change that plus to a minus. And there is a second age. There's a second age of 29.6. Now again, I would say 67. I would even take 68. I'd let you round that. Or 29 to 30, somewhere in that area. Now, again, if you don't have this fraction key and you're going to do this, make sure you say parentheses 0.35 plus second square root, that number, then put that in parentheses and now divide by 0.0072 or 0.772. There it is, and then change that plus to a minus, and there's the other answer. So you have two answers because both of those are ages. Oops, I should put years old. Okay, I think this is the last one, hopefully. Oh no, there's two of them. I'm going to finish with this one here though, and I'll save the other one for in class. The reason is this one you'll see a lot of. Usually this one happens to be an arrow that is launched directly upward at 64 feet per second from a platform. Guys, most of you would look at this and go, I can't do it. Remember, you're only reading it to find out what H is and what these T's stand for. That's the only reason you read these problems, and so far they haven't told us, okay? But you'll find like an arrow is launched, a ball is thrown, you're going to dive off of a diving board, things like that where you go up and then it comes back down. It says the formula this describes the arrow's height above ground h. So that tells us by reading the problem, this is the height in feet. T seconds. So these T's are our time, and they're in seconds. That's the whole thing. That's all why we read this problem. It says the arrow misses the platform on its way down and eventually strikes the ground. Okay, so what happens is you got this arrow that's up here. It's going to be launched, it's going to miss some platform, it's going to come down, it's going to strike the ground. Okay? All right, how high is the arrow after 2 seconds? Okay, so what we're going to do, where does that 2 go? It's seconds, so wherever you see a T, that's where you're going to put it. H equals -16 times 2 squared plus 64 times 2 plus 80. Just let your calculator do the work. You're going to say -16 times 2 squared plus 64 times 2 plus 80 is going to be 144 feet high, because remember H is in feet. When will the arrow be 128 feet high? When is our time? This is our height in feet, so we're going to put that 128 here. We're going to say 128 equals -16 t squared plus 64 t plus 80. Have it set equal to 0. We're going to get 0 equals -16 t squared plus 64 t minus 48. Okay, so now you can try to factor it. You can find, I'm going to see if it'll factor. Now I can go straight to plugging it into quadratic formula. Okay, it's not going to kill anything. Okay, I'm going to see if it factors, because I know 16 goes into all of them. I am going to factor out a -16. This is going to give me a positive t squared. That is going to give me a -4t, and this is going to give me a positive 3. Because again, -16 times t squared gives me that. -16 times a -4 gives me a positive 64. -16 times 3 gives me -48. Now, that factors. I don't worry about this because we're solving for t and it does not have a t, so I don't worry about it. But it will factor. You can still say this. It's going to factor as t minus 3 and t minus 1. Now again, I'm solving for t. I don't care about this factor here. It doesn't have a t. So I'm going to take anything with a t and set it equal to 0. I'm going to add 3 to both sides. And I get t equals 3 seconds. I'm going to add 1 to both sides. And I get t equals 1 second. Both of these times are positive, and that is fine, because you've got to think about this. You're shooting the arrow up. It might hit at 128 right here on the way up, and then on the way down it might hit it there the same time. So that's why two answers are okay. If one of these had been negative, you got to kick it out. These, you'll be asked this. It'll be on your quiz. It'll be on your test. When will it hit the ground? Guys, this, the ground, is 0. The ground would be 0, so your h is 0. So you plug 0 in for h, and you have negative 16t squared plus 64t plus 80. Because again, it gets into the original problem up here. You just plug 0 there. Okay, 16 will go into all of them, so let's see. I'm going to factor out a 16. Now again, you can use quadratic formula from the start. I just don't want to if I don't have to. Minus 4t minus 5. Oh, it does factor. Oops, sorry, you can't see it. So I factored out a 16. And I got this. Okay. Now, 0 equals t minus 5 and t plus 1. Again, anything with a t you set equal to 0. T minus 5 equals 0. T plus 1 equals 0. Add 5. And you get t equals 5 seconds. Over here you subtract 1. And you get t equals negative 1 second. Time can't be negative. We can't go backwards in time. Okay? All right. What is the height of the platform? Okay. The height of the platform, we don't, that would be at our time being 0, because it's being thrown right here. It's being thrown from a platform up here. And so at that time, this is our time, and this is our height. Well, we want to know what that height is. Well, our time hasn't been thrown yet, so our time is 0. So what I'm going to do is wherever I see x or t, I'm going to plug in 0. Our original formula looked like this, so I'm going to put 0 here and 0 here. So I'm going to have h equals negative 16 times 0 squared plus 64 times 0 plus 80. Well, that gives me 0. That gives me 0. The height is going to be 80 feet. So that platform was 80 feet high. Look what happens. It's right there. It's always going to be that constant. Okay? Now, I will do this one in class. So